Chapter 3, Matter and Energy. Section 3.1, Classification of Matter. We said at the start of the course that chemistry is the study of matter and its reactions and composition and so forth. Let's revisit what matter is. Matter is any material that has mass and occupies space. Matter can be classified as either a pure substance or a mixture. A pure substance is a type of matter that has a fixed or definite composition. And we have two subcategories of pure substances, elements and compounds. Elements are the simplest type of matter, and the periodic table lists all of the elements. Okay, you have a periodic table in your textbook, the first page or the inside cover, right? And in chapter 4, we will be going into much more detail with the periodic table. I have this exact periodic table in Canvas also. You can print it out, but we'll really be looking at it in chapter 4. But the periodic table lists all of the elements. And just for example, oxygen, nitrogen, carbon, oxygen has the symbol capital O, nitrogen capital N, carbon capital C. And then you have some other elements that are listed with two-letter symbols, such as aluminum would be capital A, lowercase l, and so forth. Like I said, we're going to talk more about the elements in the periodic table in chapter 4. But elements are the simplest type of matter. I have some samples here I can show in the video. I have sulfur, symbol S, it's an element. I have an aluminum rectangular prism, element. I have gold foil, pure gold. It's not much. Okay, pure gold. Okay. And copper, in the form of copper wire. Okay. So these are all examples of elements, which are a category of pure substances. The next category of pure substances would be compounds. Compounds are a combination of two or more elements that are chemically bonded together. And some examples of common compounds: water, H2O, you have two hydrogens bonded to one oxygen. Carbon dioxide, one carbon bonded to two oxygens. And you have many examples of compounds as well. Sugars are compounds, alcohols are compounds. There's many pure substances that are compounds. Salt, sodium chloride. So combination of two or more elements chemically bonded together. Well, what happens when you have something that is in the category of a mixture? Let's define the categories of mixtures. Mixtures are two or more physically combined substances. And there are two categories of mixtures: homogeneous and heterogeneous. A homogeneous mixture has the same composition throughout, or a uniform composition throughout. And some examples, just to give you an idea, salt water, soft drinks, the air we breathe, are homogeneous mixtures. I have here a bottle of Gatorade. Gatorade contains water, sugar, dextrose, citric acid, natural artificial flavors, salt, sodium citrate, potassium phosphate, okay, and some other ingredients as well. It's mixed the same throughout. Whether you look up here or down here, it's the same throughout. The composition, all those substances are mixed the same throughout. Now that's a much more complex homogeneous mixture than if I just take plain old water and put a little bit of salt in here. get it all to dissolve. And I have a homogeneous mixture. The same composition throughout, top and the bottom. Same composition, homogeneous mixture. Okay. Heterogeneous mixture, you do not have the same composition throughout. One part of the sample may be different than another part of the sample, such as a salad, okay? I have a lot of different things in my salad. Lettuce, tomatoes, olives, cheese. And one part of the salad may not be the same as the other part of the salad. If you look at the top, there's more lettuce. If you look at the bottom, you can see through the container, it's more olives and has more olives and has more tomatoes. Okay? That is a heterogeneous mixture, not the same throughout. Okay, look at party mix, okay? Look at all these things in here, okay? It's not the same throughout. It's a prefix homo meaning the same, hetero meaning not the same. So you have mixtures that are the same throughout and not the same throughout. And I'm sure that you can think of many examples yourself about what is a homogeneous or a heterogeneous mixture. Section 3.2, states and properties of matter. This section discusses physical and chemical properties. In the previous section, under classification of matter, the terms physically combined, chemically combined, were interspersed in definitions. So we're going to talk about what those terms mean in this section here. What are physical properties? Physical properties can be observed or measured without affecting the identity of the substance. So when you say that something has a particular shape, a particular color, odor, density, freezing or boiling points, these are all examples of physical properties. And you say that that powder is white. The color of the powder is a physical property. And you say the blue liquid, okay, the color is a physical property, and saying that it's a liquid, which is the state of matter, is also physical property. Okay, so these are just examples of physical properties. State of matter is a physical property as well, if something is a solid, liquid, or gas. Let's look at the states of matter in a little bit more detail. Solid shapes have a fixed or definite shape to them. Okay, this shape does not change, it stays consistent. If you look at this marker here, this plastic marker, it has a fixed or definite shape. It doesn't change. It's not bendable or flowing, okay? It has a fixed or definite shape. The volume is a fixed or definite volume. Okay, if we wanted to get the volume of this, it's roughly cylindrical, but it does have an irregular shape. We could use the displacement method to get the volume of it, as mentioned in the previous chapter. But it has a fixed or definite volume. It doesn't change. Well, why do solids have a fixed shape and a fixed volume? It's due to what they are like on a particulate level. Little to no room to move. Tightly packed particles. They're kind of just crammed up against one another, and they really don't have anywhere to go. So it gives them a rigid shape. It gives a fixed volume to that state of matter because the particles have little to no room for moving. They're packed in a crowded elevator. They can't go nowhere, okay, for an analogy. Liquids. Liquids have a variable or indefinite shape. I have here a bottle of water, and if I hold the bottle this way, the water has a roughly cylindrical shape. If I hold the bottle this way, the shape changes. If I hold it this way, it has yet a different shape. So the shape of a liquid is variable. It can change. The volume of a liquid is fixed or definite. This water bottle here, I drank a little bit out of it, so it has less than 500 milliliters. And maybe it has about, 475 milliliters. I only took a little sip. So regardless of which way I turn the bottle, the volume is the same. The volume is roughly okay, that amount, regardless of which way the shape is formed of the liquid. So it has a fixed or definite volume. So liquids have a variable or indefinite shape, but they have a fixed definite volume because the particles that make up the liquid can slide past one another. They have a little bit more room to move as opposed to a solid where it's very rigid. Then we get to the gaseous phase of matter. And the shape of a gas is variable or indefinite, as is the volume being variable or indefinite, because the gas particles are random free-flowing particles. Now later on in chapter 11, we're going to talk a lot more about gases in detail, but you can change the shape of a gas. Okay, if I have a syringe here, and I'm going to put my finger here, okay, and I'm going to trap a certain volume of air in here. By applying pressure, I'm now changing the shape and I'm changing the volume. Okay, I haven't let go of my finger off of here. My finger is on here. I've changed the shape, okay, and I have changed the volume. Gas particles are random, free-flowing. They're always in constant motion, which therefore allows for the shape to change, variable, indefinite, and the volume to change as well. What is a physical change? A physical change is a change that occurs that does not affect the identity of the substance, such as a change in a state of matter, cutting a substance, grinding, dissolving a substance in water, melting, boiling. All of these are examples of physical changes. You do not change the identity of the substance when something goes through a phase change, change in a state of matter. If you have a solid ice cube of water and you let it melt, it then forms liquid water. If you leave the liquid water out under right temperature conditions, it will evaporate. It'll go from a liquid to a gas. You still have H2O when it's in ice form, when it's in liquid water form, and when it's in the form of steam and has undergone evaporation. So physical changes, you do not change the identity of the substance. Sorry, I'm trying to play with this video screen here. Why is it not? Sorry, got a little bit. Why is it crooked? There we go. Sorry about that. Okay. If you have something and you cut it or rip it apart. I have a paper towel here. Cut it, rip it apart. It's still the same substance. It's still the paper towel. Okay, if you have wood and you're grinding it, you still have wood, whether it's wood chips or a big wood block. Dissolving a substance in water. Now that's one that people get a little bit confused on. But let's explain it, okay? If you have salt and you dissolve the salt in the water, you still have the salt and you still have the water as separate entities. They're just mixed together. In the earlier video, to show an example of a homogeneous mixture, I made salt water. I put salt into a beaker of water and mixed it. If I were to let that beaker sit out, over time the water would evaporate. It would go from a liquid phase to a gaseous phase, and what would be left in the beaker is just the salt. So you can do these processes of separation and still have the same components of that mixture. That's a physical change, dissolving a substance in water, okay? A lot of island and coastal communities get water from the ocean. Now you say the ocean is salt water. Well, they use the separation process, desalinization, to separate the salt out of the water. So they have giant mounds of salt, and then they have the water that is, so through a series of piping, is treated for use, for human consumption and usage, okay? The words melting, boiling, evaporating, they just describe a phase change. You still have the same substance. Okay. Then you have the term chemical properties and chemical change. This describes something a little different. Chemical properties describe the ability of a substance to change into a new substance. When you buy a material and it says that it is flammable, okay, maybe you have a lighter to light candles at home, and one of the warnings on here is that it's flammable. Well, it means that it can catch fire. Okay, the butane lighter fluid in here is flammable. Corrosive, from the Latin corrodere, meaning to gnaw at, to eat at. Something that is corrosive, particularly an acid, has this chemical property. It will react with metal, so here it's showing reacting with a metal pipe, and it will react with skin tissue as well. Okay, so flammable and corrosive are words that are chemical properties. They describe the ability to ignite. Flammable, corrosive, the ability to react with metals or skin. Okay, this is an example of something that reacted with something corrosive. Okay, which brings us now to chemical change. A chemical reaction. Substance changes into a new substance with a different identity. This here was a copper fitting. Okay, bright, shiny copper. Over time, it reacted with corrosive substances and formed this green material on here, which is either copper nitrate or copper sulfate. Okay, that's a different substance than copper, right? So words like rusting, burning, tarnishing, seeing a color change are all examples of a chemical change. We're going to talk about chemical reactions in detail in Chapter 8 when we learn how to balance equations, and we learn a lot more about chemical equations. But you have these examples for chemical changes, and these examples for physical changes. In addition, in your textbook, tables 3.3 and 3.4 give you more examples of physical and chemical changes and more examples of physical and chemical properties. Before I conclude this segment, this video, here's a candle. Okay, if I light the candle, okay, the wick is burning. Okay, the wick burning is a chemical reaction, a chemical change. That wick is going from a white color to a charred blackened color. You have a color change. Okay, heat is given off. But what's happening with the wax is starting to melt, but it's still wax. So you have the melting of the wax, which is a physical change, and the burning of the wick, which is a chemical change. So physical change, the melting wax; chemical change, the burning wick. Okay? So the wax is starting to melt. Pour it into the glass here, okay? So that's the physical change, but the burning is a chemical change.